Hello, and welcome back to day 15 of 100 Days of Clarity. I know I say this often, but today truly is a super exciting day because it is the very last lesson before we write our full-fledged smart contract. And again, comparing this tutorial to other tutorials, it's clear that, we opted to hammering away the fundamentals before we actually write a full-fledged contract. Though again, if you look through the contracts that we've written so far, Clarity Basics 1 and Clarity Basics 2, there's a plethora of functions in there and a lot of functionality. But we can't consider that a standalone smart contract quite yet. Today, though, is a final lesson before we jump into that. And this final lesson has to do with writing multiple steps in a function. And I'm not sure if you noticed that, but up to now, we've only written functions where the body was a single parentheses. Yes, there were other functions and other parentheses that maybe we placed inside there as inputs, but for the most part, for all of it, the body has been a single function. Now, it's been useful, but obviously that's very, very limiting. And so there are two words or two functions that you can use in Clarity that allows you to write much larger and extensive functions. Today, we're going to review one of them, which is begin. The second, which is let, is actually what you'll use 90 to 95% of the time once you're up to gear. Begin is certainly much easier to understand and much simpler, though again, it's not as powerful as let, as we'll see later on. So with that being said, open up our terminal. Today we are doing day 15, the day before our first smart contract. So day 15 in the comments section, and today let's call this begin. And we're actually going to write two larger functions that tie in a couple of the things that we've been dealing with before. So comment here, first we're going to write a function that says set and say hello world. Just say hello. And then the second, we're going to have a function that we're going to have a counter that increments only by even. Okay, so let's write our first function. And I'm not going to go over them today because I think that'll be a great point for tomorrow. But I am going to preview what comments look like when we write actual functions here. So okay, let's go ahead and first, we're going to, for our first function, set and say hello. We're going to go ahead and describe it. And so this function allows a user to provide a name, which, if different, changes a name variable and returns hello new name. Okay. And so just from that, again, I usually have these two comments before any function. At DSSC stands for description, and at param stands for parameters. We know we're going to need at least a new name. And we can call this a string ASCII, let's say 48. That represents the new name. Okay. Now that we've written this out, we know that we're actually going to need a name variable to change. So let's first go ahead and define data, var, and let's call this hello name. And it's going to be a string ASCII 48, and we're first going to set the value to Alice. Okay, and so now we're going to write a function, and again, the point of this function is we're going to allow a user to submit a new name, and if this new name is different, then we will change this variable hello name, and then we will spit out at the last line hello this new name. So let's go ahead and do that. And again, the point of this exercise is to use begin and to mix and match all the logic that we learned previously. So we're going to use asserts here. So define public. Let's go ahead and call this function set and say hello. And we know that the parameter needs to be at least new name string ASCII 48. And we can just press enter, enter. Okay. Now we're going to go ahead and use begin. I will say the syntax that this provides isn't, it's useful, but it kind of gives the misconception that it only allows for one or two expressions. Again, begin is one of those functions where you just want to immediately press enter, enter, because everything in the middle is going to be indented as its own functions or its own lines of logic. Okay. And again, I usually like commenting every step that I'm going to do before writing this out. I suggest getting in this practice as well, though it will take time. Okay, so first let's think through the fail scenarios. Well, we know we don't want this to update if the string is empty. Okay? And again, whenever we have a conditional where we know that if it fails, we don't want it to go through, that hints at using asserts. So first, I'm just writing in comments, assert that name is not empty. Okay, cool. Because if it is empty, we don't want to update it. I guess another fail scenario is we also don't want to update it to the same name, right? Because that's boring. So we will also assert that name is not equal to current name. Okay, and with that, we have two asserts. If that works, then we know we can update our name. So let's go ahead and the next, and again, we're just commenting here. We're not writing out. I'm aware of the error messages. The point here is to flesh through the logic before you write the functions. So assert that the name is not equal. And if both of these check out, then cool. Then we want to var set the new name. And if that works out, then cool, we want to say hello new name. And again, since this is a public function, we know it needs to end in an OK message. So just to quickly get rid of these error messages, just write OK true at the end. As you can see, we got rid of the error messages. And now we can go back and write our functions one at a time. So assert that name is not empty. Okay. Well, again, we know we need to write asserts. So asserts, and we need to check that it is not empty. So, well, we know how to check if it is empty, right? We could do is equal, just like we're going to do here. We could do is equal var get hello name. Because again, we need to check is new name equal to hello name. New name. And then again, error messages, let's write in integers from now, and we're going to go back and later replace them. Okay, but right now all this function will do is it'll check that the new name is equal to the old name, which is what we don't want. We want the inverse of that. And whenever we want the inverse of that, well, that's when we use the not function. So here we're going to go ahead and wrap this around not. Save, and that should work. So now to our second function. Assert that name. Sorry. I'm going to copy paste this below. I was doing this step here. Now it's accept that name is not empty. Well, again, we can keep the not and the is equal to, and all we want to do is check that var name is not equal to an empty string. Very simple. I will say though, let's change the second error message to U2. So we remind ourselves to change them to different error messages because they fail at different times. And we press save, that worked. If that works, then cool. Then we want to var set our new variable. This is pretty straightforward. We want to var set hello name to new name. Cool, simple, that worked. And our last step is we want to say hello to new name, which we know is going to be a concat function, one of the very first functions we saw. So concat hello, and let's give a space so that the name doesn't require a space, and then var get hello name, which should now be new name. And that's it. So the only thing left is we're going to wrap our last function around OK, because again, the last function always has to be a response type whenever you're using a defined public. Cool, and if we save, we see that everything here works. So before we test it out, I'm just going to write one more quick define read only function that'll show who hello name is at the moment. So read hello name, and then we're just going to return var get hello name. Okay, and if we save, let's go back to Clarinet console. And yeah, I mean, this is an exciting step. As you can see, our functions now look, more so like professional functions. There's multiple steps here. We're adhering to, the Clarity standards of security by asserting a lot of our fail cases. And so first, let's go ahead and just read hello name. So read hello name. We expect to get back Alice. And indeed we do. So now let's call set and say hello. And feel free to type in whatever name you want. I'm going to pass in set Zeus. Set and say hello. And again, you're writing the parameter directly here. And you see the response. Okay, hello, set Zeus. And if we go up arrow twice and now call read hello name, we will see that we indeed get back set Zeus. Cool. So yeah, I mean that. As you can see, that's a pretty powerful function. We're going to write one more quick function like this that uses a couple different operators we already visited as well. But I'm going to do this one a lot faster. So, if you get lost here, put this on 0.75 speed or something, watch it, write these functions out, and make sure you're following along. Because again, tomorrow is the first day where we write a full smart contract. Okay. This next function we're going to do, we already said we want to count by even, right? So first, let's go ahead and just define a counter. We're going to call this counter, and we know it needs to be a uint, and we want to start at u0. Okay. Same with read hello name. We want to be able to read the counter whenever we're testing this. So let's just write a quick read-only function that just reads this counter. Okay, and now we're going to write in the comments that'll help us with our main function, which is increment counter even. Okay, so at description. Well, this function allows this function allows a user to increase the counter by only an even amount. And for the parameter, what that means is we're gonna call our variable add num, and that's going to be uint that the user submits to add to counter. And again, we're only going to add if it's an even. So let's go ahead and write the body of this function out. We know it's going to be a defined public because we're writing. We're going to call it increment counter even. We know that we need one parameter, which is add num, which is going to be a uint. And then for the body, we know we're going to need a begin function because we're writing multiple lines of code here. Okay, now let's start commenting in what we actually need for lines of logic, right? And this one is a little bit more simple than the last one because all we really need to check is the input provided an even number? And how do we check if a number is even? We actually did this in a previous exercise, but in case you don't remember, we use the modulo operator. And again, modulo tells us the remainder of one number being divided by another. And so if the modulo is 0, when we divide it by 2, we know that's an even number. So first line here, we need to assert, because again, if it's not even, we don't want it to add. We want this to fail, actually. Assert that add num is even. And that's kind of all we need. So if that works through, cool. Increment and var set counter. Straightforward. We only need 2 lines of logic. Again, since it's a defined public function, we need to have OK response somewhere so Clarity doesn't error out. So we'll add that temporarily. All right, and our first line of logic, assert that add num is even. Again, we know we need an assert, and we know that we need to make sure if it's even, and the way we make sure if it's even is if the number divided by 2, by modulo number divided by 2 is equal to 0. So we know we need an is equal, and we know that one part of it needs to be u0. The second part needs to be modulo the number that's being provided add num, and then u2. And again, for our error messages here, I'm just going to call this u1 very simply. Oh no, u3, because again, we haven't listed out error messages for neither of these functions, so we're just continuing 1, 2, 3. Okay, and then increment and var set counter. So this is going to be straightforward. We know we need to var set. Well, and what do we need to var set? Well, we need to var set our counter. And what are we var setting it as? We're var setting it as our current counter plus the new number provided. So our current counter, which is var get counter, plus the number provided, add num. Okay, and if we press save here, we'll see that this indeed does save. So this should work. If we go back to Clarinet console, let's run this. First, let's just check and read the counter. Should be 0. Indeed it is. Let's go ahead and try incrementing counter by not an even number. So let's call it u1. And I got... Oh, sorry, I misspelled increment counter. Okay, and we got error message u3, which if we look here, that means that the number was not even, which indeed u1 is not. If we type in u8, which is even, awesome. We get an OK true message, and if we check read counter now, it should be 8. It is. Let's try increment counter even by 8 again. We should have 16, and we do. Okay. And yeah, we went a little bit longer than necessary, but I think it was critical to show you guys how begin and let expands the body of a function and lets us really, really customize and expand them as much as we need, which obviously is going to come in handy when we write in our own smart contracts. That's going to start tomorrow. So thank you for sticking around this long. Tomorrow is going to be a change of pace, and from then on, the course will look very, very differently. So congrats on getting this far, but this is only the fundamentals. So I will see you tomorrow.